Alright class, welcome to lesson 7.8. This one is factoring by grouping. It's a style of factoring that we're going to teach first because we find that this one actually is one of the most applicable styles across all factoring problems. To start, I want you to graph this one. I want you to solve this one out and then graph it on Desmos. So I will come back with 5 seconds and start to solve it myself, but actually pause this video and solve it on your own. Alright, so with this one, if I'm solving this one out, remember I have to use my zero product property, so I need to make both of these things equal to 0. And I'm just solving this through, so one of my answers could be x equals -5, and my other answer could be 2x equals 6, which really becomes x equals 3. If you were to graph this on Desmos, you would have a positive slope, or a positive parabola, with intercepts at the point -5, 0, and 3, 0. So your parabola would actually look something like this. And again, you'll notice that these points, when we say we're solving for it, when we graph these problems, we're actually finding the x-intercepts where they cross the x-axis. Alright, so your learning targets for today is that you can factor by grouping and that you can factor things completely. Alright, so factoring by grouping is a way of using the distributive property to help you factor, especially when you have 4 terms. So a big thing to make note of here is this is definitely used when we have 4 terms. To do this, we're going to group this into pairs, and then we'll factor the greatest common factor out of each pair of terms, and then we'll continue to factor again, and you'll see what that looks like here in just a second. So again, we are going to factor the first 2 pieces and the second 2 pieces in each one of these. So for the first one, when we say what multiplies into x to the third and 3x squared, well, in both of these we would have an x squared, so we could factor out an x squared, and then we'd be left with x plus 3. Now for our second one, we're just factoring these 2 items. So we're saying, okay, greatest common factor, the factor of 2x and 6, the greatest common factor here is a 2. So we could say this is going to be a positive 2, and then this would become x plus 3. Now we're not done yet because we notice that this has something times x plus 3 and this has something times x plus 3. So we're actually going to rewrite this first with the x plus 3, the thing that is shared. Then we'll write it out as x squared plus 2, as we get the x squared from here and the plus 2 from right there. So again, this is factoring by grouping. You take a 4-term polynomial, you factor just the first 2, you factor just the second 2, the last 2, and then once you factor those, you should get a like term, which means then you can multiply the coefficients of those like terms along with the like term down here. We can also do this with just variables. And again, you do just the first 2 and just the second 2. Now, the one thing you would want to do first with this one is you would want to put it into an order. And you'd want to put that order to be like the following, because right now x squared and y, they don't have anything in common, but you could move some things around. So we're actually going to move this around a little bit, and we're going to rewrite it to be x squared plus x plus y plus xy. So now that we've done this, now we can factor the first 2 and the last 2. So the first one's x multiplies into both, so we'd be left with x times x plus 1. And on the second one, y goes into both of those, so we'd have plus y times y plus 1. Again, we notice that, oh, sorry, not y plus 1, we'd have an x plus 1 here. Again, we see that we have an x plus 1 in parentheses for both of these, so we're actually going to rewrite this as x plus 1 times x plus y. And again, we're getting the x plus 1 because we factored out pieces that left x plus 1 in both of these cases, and then we get the x plus y from the x and the plus y here. So some things can be factored completely, some things cannot be. If they can be factored completely, it means that what you get them down to you can't break apart anymore. So for example, x squared minus 1 can be factored because of the plus and minus 1 feature. We learned about this when we were doing special products. But some things cannot be. So like if you have something squared plus a positive, it's not going to be able to be factored. So this is the smallest it can become. Let's see what this looks like on the next couple problems. Again, here's some general guidelines for factoring completely. You want to write down all this stuff. It can be helpful. Write down the examples and go with it as well, but we will be showing how to make use of this in just a moment. Alright, so for these ones, again, we do want to factor these things completely. So when we're looking at these, we'll notice that there are only 3 terms on this first one. So I want to see, is there anything that multiplies into all 3 terms? And for this one there is, you could multiply a 3x into all 3 of these terms. So you would be left with x squared plus 2x minus 6. Once you get to this point, you now could say, could we break this apart any further? However, this second one here is unfactorable because there's nothing that multiplies to 6, negative 6, and adds to positive 2 here. So this is as far as we can get with this one. Sometimes this will be as far as you can get. Other times you are going to be able to break these things down even more. Let's look at B. I'll use a different color for it. So with B, we have 7x to the 4th minus 28x squared. So 7 multiplies into both, and x squared multiplies into both. So we can break this apart into 7x squared times x squared minus 4. At this point, we are able to factor this some more. And we notice this is the difference of squares. When we learned this earlier, where we can do, if we have minus this, we can break this apart. So this would break apart into x plus 2 and x minus 2. We can't forget about that 7x squared though, so do not forget to bring that down. And again, recapping, the first thing we did was we factored out the 7x squared because that multiplies into both pieces. Then we took the x squared minus 4. This is factorable. It's a difference of squares. So therefore we can do x times x is x squared. Positive 2 and negative 2, when you multiply these things together, we get to the negative 4. And this would also allow us to cancel out the in-between items as well. Our last one for solving and factoring completely, this is the first one that said solving, so remember that when we do solve, we need to get it down to x equals a number, so we do need to actually get it down to values. So in this case, the first thing we want to do is put everything equal to 0. So we would rewrite this first as 2x to the 3rd plus 8x squared minus 10x equals 0. Alright, well the first thing we want to do is figure out, is there anything we can remove from all pieces to make it more simplified. Notice all of these are even numbers, so we can definitely divide everything by 2, and they all have an x in them, so we can divide everything by an x. So we're going to divide 2x out, or we're going to factor 2x out because that's the greatest common factor, and then 2x times x squared, 2x times positive 4x, and then also in here we would have a minus 5. Now when we look at this one, we see that we have to multiply to negative 5 and add to positive 4. We can do that by doing negative 5 and positive 1, or positive 5 and negative 1. So this would break down to x plus 5 and x minus 1. And again, we have that 2x come down. Now, because we are solving this equal to 0, and we are actually solving this out, remember we have to figure out what makes this 0. And if this is 2 times x times the quantity x plus 5 times the quantity x minus 0, it's whenever any of these three pieces become 0. So we would have 2x is equal to 0, we would have x plus 5 is equal to 0, and we would have x minus 1 is equal to 0. So in all three of these cases, the first one, it would become x equals 0 because divide both sides by 2. The next one would be x equals negative 5 because you'd have to subtract the 5 over. And then here x equals a positive 1 because you'd add the 1 over. So our answer in all three of these cases would be those three values. These are the three values where the x-axis would be crossed. That's all we have for today. If you have any questions on the homework, let me know.